Today we will be looking at virtual machine configuration. We'll be looking at the files that comprise virtual machine and the location, and when they are together, how they transform into a fully functional virtual server. Some of the virtual machine files of that should be understood clearly are the configuration file, the swap file, BIOS, log, virtual disk files, and snapshot files. The configuration file, or the VMX file, is a small editable file. It's about 200 to 400 bytes in size. It includes all the information that is required to represent a virtual machine. It includes information on devices, includes the virtual hardware version, and a number of other details. The swap file is storage on the data store that is required by the hypervisor in the event of memory contention to be able to swap memory contents out to disk. It is only available or required when the virtual machine is powered on. The BIOS file is represented as the NVRAM, the BIOS on the virtual machine. Log files allow a VM admin to troubleshoot and determine any issue with the virtual machine. Virtual disk files are the VMDK files. These are represented as the CDE drive as an example for Windows machine. The snapshot files are available if the virtual machine has a snapshot and it shows up as a snapshot file. On ESXi hosts, the virtual machines are located in a certain very specific folder structure, and it's always prefixed by /vmfs/volumes. As an example here, /vmfs/volumes/datastore1, which is the name for data store in your organization. It could be different, and followed by CentOS, a folder where that VM is located. The folder structure most of the time maps to the actual name of the virtual machine. All the files describing the virtual machine, including virtual disk, swap file, log, snapshot files, they're all located on a shared data store. And a data store that is shared between ESXi hosts allows migration of VMs from one host to the other. If we take a deeper look at this actual output of one of the folders, we can tell that we have the CentOS.vmx file, and this indicates that in all probability the name of the virtual machine is CentOS, running the CentOS version of Linux. This file, you can see, is about 2700 bytes in size. The next one is the NVRAM, which is the BIOS for this VM. We also have some log files which are capturing information about the VM and can be helpful in troubleshooting. Then we see the .vmdk and -flat vmdk. The thing to note here is that these always come in pairs. The descriptor file is the CentOS.vmdk, which is between 300 to 500 bytes in size, as shown here, and the descriptor file describes the disk, the size, if it's read-write, if it's read-only. All of that information is captured in the descriptor file, and it points to the actual binary disk, which in this case has the same name except that we have -flat added to it, and this is the binary disk. While the CentOS.vmdk is a descriptor file and can be edited, the binary disk cannot be, and it contains the actual data. We also see a CentOS OS ending in vSwap. This is the file that is created on the data store. The size most of the time is equal to the size of the configured memory. So looking at this output, one can tell that the size of the virtual machine, the memory configured on it, is 2 gigs in size. And we also have a CentOS.vmsd, which is the snapshot descriptor file, and as it shows here, the size 0, indicating that the VM does not have a snapshot at this point. This slide shows two outputs taken from an the actual file. So on the left we see an example of a VMDK descriptor file, and if we look closely, A lot of details are available here, including the file format, the read write, the size, the actual binary disk that it's pointing to. So all of that information is contained here. In addition, we see there is the adapter logic, which is LSI logic. We also have information about the geometry of the disk. The graphic on the right hand side is an example of a virtual machine VMX file, and we can see that information about the VM, including some devices and drivers, it's all included here. Both of these files are small in size and are editable. When we talk about virtual devices, we notice that the virtual machine can support up to 4 SCSI adapters. We know that one SCSI adapter can support up to 15 devices, so a total of 60 devices, and most of the time these devices are used to connect to disks. We also note that the virtual machine is able to support up to 4 terabytes of RAM. In fact, for the latest version of VMware, vSphere, which is 6.5, support has gone up to 6 terabytes of RAM per VM. To support symmetrical multiprocessing, the virtual machine can support up to 128 virtual CPUs. We also notice we have capability to connect up to 10 different network subnets using 10 VNICs. A relationship of VMs running on an ESXi virtual machine may run on a number of places, including ESXi host within a data center, clusters, or part of a resource pool. Multiple virtual machines coexist on an ESXi host in complete isolation, and they are sharing the resources among other virtual machines, as shown in the picture here. A quick review of the section. A virtual machine is represented as files in a certain folder structure. The virtual machine has its own virtual hardware comprised of virtual NIC, virtual disk, virtual memory, and virtual CPU. A virtual machine is able to share resources of the host, typically CPU and memory, with other virtual machines. In the next section, we will show installation of ESXi host and virtual servers. So stay tuned, and we will follow up with the next section. Thank you very much.